All right, so let's try that again. X squared minus 11x plus 28. I'm going to make my chart. Again, I'm looking to put a value here that I have to multiply. Value here is the two numbers have to add up. So we take our last term. So I'm looking for two numbers that multiply to give me 28, but those two numbers have to add up to give me the middle term. So I'm looking for two factors. Notice that they both have to get a positive 28, either both of the numbers have to both be positive, because a positive times a positive is a positive, or both be negative. Negative times a negative is a negative. Since I'm looking for a sum that's negative, that's kind of telling me that my two numbers have to be negative themselves. So now we take a little look. I've got to know my factors of 28. What goes into 28? In this case, the only thing that's going to work is going to be -4 and -7. So I'm going to take those two numbers. I'm going to rewrite them, or rewrite negative 11x using those two numbers. So now I get x squared minus 4x minus 7x plus 28. So again, we've just changed the look of the problem, changed it from a 3-term problem to a 4-term problem, and now we can factor by grouping. So group, group, and we take out the GCF of each group. Greatest common factor here is x. When you divide x out of each term, you're left with x minus 4. Plus, again, because that's a negative here in front, we're going to factor out a negative because our goal is to get something times x minus 4. And if we factor out a -7, that -7x divided by -7 leaves you with a positive 4. And a positive 28 divided by -7 is also the -4. Smiles, 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 because those two values are the same, which means the greatest common factor between this group and the greatest common factor of this group happens to be x minus 4. If we remove that factor from each group, you're left with x minus 7. Final answer. Again, take a look at the work, take a look at your answer, see if you can see the shortcut. All right, so our next example, x squared minus 2x plus 2. 3 terms, no GCF, so we start to set things up. So I'm looking for factors of 2 that add up to give me -2. Now, you're perplexed about your factors, start listing them out. Start a running list of what two numbers can multiply to get me a positive 2. 1 and 2, -1, -2, and that's pretty much it. So now, that's it. Those are the only two numbers that you can multiply together to get a positive 2. The problem is, none of these will add up to give you a -2. So what's the answer to this problem? Well, if you can't find two factors that work, there is no solution to this problem. Now, what's kind of cool is we actually have an answer to this problem, but it's not possible. It is prime. So anytime we have something that cannot be factored, just like prime numbers, this just means the polynomial is only divisible by itself and 1. Anything that is only divisible by itself and 1 is considered to be a prime. So answers for polynomial factoring could potentially be prime. All right, our last example should look a little different from all the other ones, because this time there seems to be a y and a y squared that have snuck into the problem. However, because of the fact that we still have a 1 in front of x squared, we can still factor this in the manner that we've been factoring the other examples. So back to my little chart I go, and again now I'm looking for factors that multiply to give me 16, and they add up to give me 8. So that process isn't changing. What's going to happen to the y? Well, you'll find out. So, two things that multiply together that give me a positive 16 but add up to give me a positive 8. That would be 4 and 4. And just like before, I'm going to take those two numbers and I'm going to use them to rename the middle term. Now, instead of having an x in the middle term, we have an x and a y. Not a problem. That just makes that 4xy plus 4xy plus 16y squared. So we just renamed it. Again, now we just continue to put all the variables that were there versus the other ones. So now, again, Four-term problem, group, group. Taking out the GCF of each group, there's an x in common, leaving you x plus 4y. Plus, here they have a 4 in common and 1y, leaving you with x plus 4y. And again, once you see that what's inside the parentheses is the same, you should be smiling, because now you can take that term and this term out of each group, and you're left with x plus 4y times x plus 4y. Notice where the y ended up? Just at the end of each one of your two factors. By the way, there is another way that you could write this. Since x plus 4y is being used twice, you could write it as x plus 4y squared, and either answer would be perfectly acceptable.